And I think we're ready to actually implement the forwarding logic now. I would like to create 2 new methods down here. So that's the base functionality of a router, to find the next hop address for an incoming destination address of a packet. And then it also needs to handle that for actual incoming packets. So there's an incoming packet right here with a destination address. Okay, so that may sound sort of similar, but there's a reason why I'm dividing this into 2 different functions. Let's provide some context to the user here. Because what I want to do is to find the next hop address by invoking the function on the object itself, find next hop address, with that same value of destination address. And this is effectively invoking this function. But I'm not only interested in invoking the function, I want something back from that function. I want the next hop to be returned to me. And when I define a function that can return something, then I can assign it into a variable. So let's just stop the implementation here and just create a to-do marker for ourselves that we need to implement the forwarding of the packet here. So let's do that later and then focus on the other method for now. So to actually make that very cool comparison that the IP address module could do for us, then I need to convert that address into an object. Like this. Because then I can loop around all the entries in the forwarding information base. And at this point in time, the forwarding information base should contain a list of dictionaries with this structure. So inside of each dictionary, we will have a prefix that is actually of the type IPaddress.IPv4 network, the built-in Python object type that we can use to compare a network with a host IP and determine whether or not there is a match. So I can just use an if statement for that. So if the address object is inside of that prefix, which is of the type IPv4 network, then I could print out found a candidate prefix, which is this one. So let's see how that code works so far. So I want my core router to process an incoming packet with the destination address of 10.5.17.4. Let's see what happens. Oh, so it received an IP packet, but without any matches. I don't see any other output here, and that's because I made a typo of 10.4, so it wasn't able to find that. Let's try with 10.5. So let's see if we can find some candidates. And it turns out we can't. So we need to do some troubleshooting here, because this was supposed to work. We're definitely running this function right here, because we see the output from received IP packet. Then the next line of Python would also have to be invoked, because Python just doesn't suddenly stop processing lines, it'll continue. So that means that our function up here is definitely also running, but it's just not finding any candidates. So to troubleshoot this, maybe it could be interesting to see how many fib entries it's actually checking. So let's just put in some basic debugging here to validate the size of the fib, and I'll then calculate the length of the forwarding information base, and that should be visible here on the output. And there's a problem right here. So the size of the forwarding information base is 0. Let's just have a look up here at the logic. And I am creating a new fib entry. And with my debug message right here, I'm stating that I'm populating the fib, but then I'm not doing anything else. So I forgot to actually append this to the forwarding information base. So with that bug fixed, let's try again. And now we see that the size of the fib is 4, and we found 2 candidate prefixes. So both of these 2 routes matches the destination IP address of the incoming packets. That's pretty neat. But we're not done yet, because we need to figure out which of these 2 candidates to use. So to figure out which of these 2 prefixes to choose and really return just one single next hop address, we need to think like the router. So our end goal is to find just one single entry in the forwarding information base that we will consider our best candidate. So when this process begins, we have no idea about what it is, because we haven't gone through that logic yet. So we'll set it to none initially. So in any case where the best candidate is currently none, so if there is not a best candidate, then the current one would certainly be the best one. But there's a chance that it'll be beaten later on by a longer prefix match. So there's another case here where the entry, so the current fib entry, you know what, let's just rename this one to fib entry to make it absolutely clear what we are dealing with. So using descriptive variable names make the code easier to read and maintain. So there's a chance where this prefix has a prefix length that is higher than the current best candidate. So whenever that happens, we can then reassign the best candidate to be the value of the current fib entry, because we have found a better one. This is a longer prefix match. Okay? So in a moment, we will check if this logic actually works. But we also need to wrap up this function by really checking if just any best candidate was found. And if that's the case, we'll just print out that best candidate. So let's use that for verification. And we see here that 2 candidates were found, and the longest prefix match for this specific destination address was indeed the /23 network out of these 2 candidates. So that's working as expected. We can also see that the contents of the best candidate is a dictionary right here. So that's the dictionary that I originally created for the fib entry up here. So that has been maintained. And it means that now I not only have the prefix right here, including the subnet mask, but I also have a next hop available. So that's what I'm really interested in returning back to my incoming packet processing down here. And I can do that with the return statement. So I'll return the best candidate and then the next hop entry of that dictionary. So that will then be assigned into my next hop address down here, because I'm calling the method find next hop address, and that one will finally be returning the actual value of the next hop. So that will be assigned into my next hop address. And it's a very powerful way of combining different methods and variable assignments that you actually return data from functions like this. just for logging purposes and good measure, let's also print a status message here in the case where we did not find a matching route. Our forwarding down here is just emulated, so we can do a verification if we actually had a next hop address, because if there's nothing returned, if we go into this else statement down here, then the value will be none. So we can just check that with an if statement. If there is something inside of the next hop address, it means that all of the logic up here was successful. So if that's the case, we're forwarding. And in all other cases, what does the router do when it cannot find the destination? It drops the packet. So let's check our logic right here. And we can see that the final decision is to forward to 192.0.2.1, which is the next hop of my /23 route. We can see that in the routing table up here. If I change my incoming packet to be .67 instead, and then I rerun the script, then I'm forwarding to the next hop of 192.0.2.3 instead, because now I actually match this /28. I can see the logic goes on here that it finds 3 different candidate prefixes. One of them is selected as the best candidate, and that's the one that is returned to my incoming packet method, and this is the one we see that is being forwarded to. So now we learned about classes and importing. Let's have a look at exceptions. So exceptions is what happens whenever you see an error in Python. We've seen plenty of those error messages. Those are exceptions. But we can handle them, and we can also generate them on our own if we wanted to. Instead of having a hard-coded destination address in here, I want to receive this from the user as input. So now I get a prompt right here. I can enter an IP address and I get the result as expected. But what happens if I enter something invalid? Like my name. It's pretty hard to forward IP addresses based on a name only. So I get an exception here. So there's a stack trace that is shown to us right here, where we can see a lot of different file names and line numbers. All of this refer to either script files or modules inside of Python. But the final message down here is what we should interpret, that it's expecting 4 octets. Which is fair, I'm supposed to input an IP address. But instead of having my program crash like this, I can handle the error. Because what if I wanted to put this into a while loop, and then I wanted to accept multiple packets one after the other? Some of them gets forwarded, some of them doesn't, and then when I type in my name, suddenly everything crashes. I don't want that to happen. So what I can do is that I can verify the contents of a variable by trying to instantiate it as an IP address. So I can ask Python just to try to convert the destination, so that input value, it can try to convert that into an IP address. And if that is successful, then I will invoke the forwarding mechanism. If that is not successful, if it can't do this, then Python will throw the exception, so the error message that we see. And I can then catch that and go into a new code block here and print a nice error message, invalid IPv4 address instead. And then the program can continue running. So that means that now if I enter something invalid and hit enter, I just get the error message, invalid IPv4 address, and I can try again. So now we also learned about the basics of exceptions.